All right, here's a little tricky kind of problem because of the generalized nature of it. We have the x to the n, and we have going from a to b. So what they're looking for here is a generalizable conclusion if given the fact that the red area, this stuff here, apparently that's red, is 3 times larger than the blue area, then that's enough information to know what power we're raising x to. So is this x squared, or is this y equals x cubed, or something else? Maybe it's a fraction power, who knows? But that's our job to figure out. The area of the blue part is going to be really simple, and I'll do that in a minute. But the area of the red part, also kind of simple, but requires a reminder of how to find area along the y-axis, from the curve to the y-axis. Remember what this is actually a type of inverse. Instead of the integral of f of x dx, we're going to integrate from we're going to integrate x with respect to y, so the integral of x dy instead of y dx. That is, we have to invert or solve this equation for x in order to be able to know what we're supposed to integrate. By taking this equation, I just take the nth root of both sides, or the 1 over n power, and I get x equals y to the 1 over n power. The other thing to remember is if we go from a to b on the x-axis, we follow a up to the curve, this is f of a. If we follow b up to the curve, this is f of b. So my boundaries are from f of a to f of b along the y-axis with respect to y. So it's all good. So the y is y to the 1/nth power. Now to anti-differentiate y to the 1/nth, I'm going to add 1, which is n over n. And then so that gives me, sorry, I should show this part. If I take 1 over n plus 1, that's 1 over n plus n over n, which is equal to 1 plus n over n. So here, we should be able to see that the power is now n plus 1 over n, which is what I said, and then we multiply by the reciprocal of that so we can undo the power rule, so that's n over n plus 1, or 1 plus n, it doesn't matter. And then I put in my boundaries. Now notice I did say we go from f of a to f of b, and here I said a to the n, b to the n, because f of a is the value of the function when x is a, which is a to the n power, and then f of b is b to the n power. And here again, I skipped some steps because I was running out of room. But if we look at putting in a to the n here, it's going to be a to the n plus 1 over n, in which case the n's are going to cancel and just give us a to the n plus 1. Same thing when we put in b to the n here, we get b to the n plus 1. You can try that by hand if you like, otherwise you can trust me. So the area of the red part, oh, I'm sorry, the other thing I forgot to mention is this is a constant. It has nothing to do with the value of x. So with constants and definite integrals, you can take the constant out of the definite integral, and it'll still give you the same result. So this is a much simpler, cleaner way to write it. But this is the total area of the red portion. Blue portion, just a simple area under the curve thing. Apply the power rule, generalized, and go from a to b. And what I notice is this area looks almost exactly the same as that area, and the only difference is instead of n over 1 plus n, it's 1 over 1 plus n. What I know is given area of the red is 3 times the area of the blue. So this is the area of the red, and this is 3 times the area of the blue, which if I multiply 3 times 1 over n plus 1, I get 3 over n plus 1. Now here's what I'm going to do. I'm going to take and color in purple all the stuff on the left that's exactly the same as the stuff on the right. And there you can see the only difference, in order to make these equal, this is n and this is 3. If n were equal to 3, then these statements would be absolutely true. So n equals 3 is the answer to the question. That means that this is y equals x cubed. So just to make sure that was right, I took y equals x cubed and found the area from 1 to 2, that's a and b. And then I took the inverse of x cubed and found the area from 1 to 8, that's f of a to f of b. And that shows 11.25 and 3.75. If I take 3 times the blue area, I get 11 1/4, which means I did the work right. So, hope that's helpful. Thanks for watching.